Okay, so continuing with the Chapter 2 review problems. I'm on page 159, number 39. The position function of a particle moving along the x-axis is given. X of t equals t squared minus 3t plus 2. And this is for all values of t. Part A, find the velocity of the particle. The velocity is the first derivative of the position function, so the velocity using the power rule is 2t minus 3. Part B, find the open interval in which the particle is moving to the left. The particle moves to the left, when the velocity is negative. So setting the velocity function equal to 0. So the particle stops, the velocity is 0 when the time is equal to 3.5 seconds. So to answer the question, find the open interval in which the particle is moving to the left. Okay, so if we look at our velocity, here's 3.5 seconds. If we choose a time in the given intervals, if I look when the time is 0 and I plug that into my velocity function, the velocity is negative when the time is less than 1.5 seconds. When I plug 2 into my velocity function, I get a positive value. So the velocity is negative, and therefore the particle is moving to the left for all values less than 1.5 seconds. Part C, find the position of the particle when the velocity is 0. So we found the velocity is equal to 0 when t is equal to 3.5. So find the position. Let's plug that back into the position function. T squared minus 3t plus 2. Squaring 3 halves, we get 9/4 minus 9 halves plus 2. So getting a common denominator of 4. (9/4) minus 18/4 plus 8/4. So we get negative 1/4. So what the negative value means, that the particle is 1/4 of a unit to the left of where it started. Now part D asks for the speed. Let's look at what the acceleration of the particle would be. Okay, so you wouldn't have to worry about the speed. The acceleration, we know, is the derivative of the velocity function. The velocity function was 2t minus 3, so the acceleration is 2. And from the quarterly, all this means is that the acceleration is constant. So the acceleration is 2 for all values of time. Okay, so for the next set of problems, 55 to 58, I'll do the even ones. 56, this is the function, f of x equals x plus 1 over x minus 1, and you're given the point 1/2 negative 3, and it asks you to find the equation of the tangent line at the given point. So equation of the tangent line, the slope comes from the derivative, so f prime of x, using our quotient rule, bottom times the derivative of the top minus top times the derivative of the bottom, all over the bottom squared. Distributing the 1 and the negative, x minus 1 minus x minus 1. The x's cancel, and we have negative 2 over x minus 1 quantity squared. Evaluate this function when x is equal to 1/2. So f prime of 1/2, negative 2 divided by negative 1/2 squared, Negative 2 over 1/4. Dividing by 1/4 is the same as multiplying by 4 over 1, so we get the slope to be negative 8. Now plugging in the information into the equation of the line, y plus 3 is equal to negative 8 times x minus 1/2. So this would be our final answer. Okay, number 58 was done on the first chapter 2 review problems that have already been posted. 62 has also been posted. So 64, our function is 20 times the 5th root of x, and the directions say to find the second derivative. Okay, so let's rewrite this as 20x to the 1/5 power, radical to rational exponent, power of the base over root of the base. So using the power rule for the first derivative, we get 4x to the negative 4/5. Now using the power rule again to find the second derivative, 4 times negative 4/5, x to the negative 9/5. Okay, so remember that 20 is a coefficient. So we just take 20 and multiply it by whatever the value of the derivative is. So then when we first find the first derivative, 4 is now a coefficient. So we just multiply 4 by what the value of the derivative is, and the power rule, x to the n power, bring the exponent down front, and then subtract 1 from the original. So now 1 fraction with positive exponents, negative 16 all over 5x to the positive 9/5. (66) h of t equals 10 cosine of t minus 15 sine of t. Find the second derivative. H prime of t equals 10 times negative sine of t minus 15 times cosine of t. So negative 10 sine of t minus 15 cosine of t. That's our first derivative. Second derivative, negative 10, derivative of sine is positive cosine, minus 15, derivative of cosine is negative sine. So negative 10 cosine t plus 15 sine of t. So that's our second derivative. All right, 70 through 80 asked to find the derivative of the function. So now we'll look at some more difficult problems. F of x equals x squared plus 1 over x to the 5th power. Okay, so we'll need chain rule here because we have this function raised to the 5th power, and then we would also have to derive the inside. I'm going to rewrite the inside so that I can use the power rule on the second term. So now the derivative, when I look at my x, the outside function is something being raised to the 5th power. Then at the same time, because I'm adding the two functions together, we'll derive x squared and x to the negative 1 using the power rule. So deriving the outside function first, bring the 5 out front, subtract 1 from the original exponent. Now multiply by the derivative of the inside. The derivative of x squared is 2x, plus the derivative of x to the negative 1, negative 1x to the negative 2nd power. So positive exponents minus 1 over x squared. There's nothing more you can do because you would have to square this by, or not square, raise this binomial to the 4th power and then distribute each term in. So leave it in this form and you're done. h of theta equals theta all over 1 minus theta quantity cubed. I know that you can't stand seeing anything other than x, so let's rewrite it. Now to find the derivative, we're going to need the quotient rule because there's a variable in the numerator and denominator. Quotient rule. Bottom function times the derivative of the top function minus top function times the derivative of the bottom. So the derivative of something being cubed, bring the 3 out front, subtract 1 from the original. Now the derivative of the inside is -1, so don't lose the -1. All over bottom squared. Okay. Don't expand the binomial. We have 1 minus x to the 3rd power. Negative x times 3 is negative 3x. Times a -1 would give me positive 3x as a coefficient. All over, power to a power, we multiply. Okay, now let's look at something we can factor out. 1 minus x, we can take 2 of those from each term. So when I get rid of those 2, I'm left with 1 here, and I'm left with 4 in the denominator. So now we have 1 minus x to the 1st power plus 3x all over 1 minus x to the 4th. So now combining like terms, 1 plus 2x all over 1 minus x to the 4th power. And that would be our final answer for the derivative. We're allowed to cancel the 1 minus x because it's present in each term, the 2 terms in the numerator and the denominator. 74, y equals 1 minus cosine of 2x plus 2 cosine squared of x. Okay, so I'm going to do one rewrite here. Since the exponent is between the trig function and the variable, the entire expression is being squared. When I look at these individually, this term is going to need the chain rule because x is being multiplied by 2. Then I'm taking the cosine of that function. When I look here, x, I'm taking the cosine of x first, then squaring the entire function. So y prime, the derivative of 1 is 0. Now working from the outside in, the negative sign, don't lose that, that's the coefficient. Derivative of cosine is negative sine of what follows it, times the derivative of 2x is 2, plus 2, again that's my coefficient, we'll deal with that at the very end. Deriving something being squared, bring the exponent out front, subtract 1 from the original. Now multiply by the derivative of the cosine function, which is negative sine. So y double prime, 2 sine of 2x, minus 4 cosine of x times sine of x. 2 times 2 is 4, times the -1 is where I get the -4, and then -1 times -1 times 2 is where the coefficient becomes positive 2. And this is not the second derivative, the first derivative, y prime. (76) y equals secant to the 7th power of x divided by 7 minus secant to the 5th power of x over 5. Okay. These 7s and 5s are just coefficients. So I'm going to rewrite these functions into more equivalent forms. So y prime, 1/7 is a coefficient. By the chain rule, the derivative of something to the 7th power, and then the derivative of secant is secant tangent. And then minus 1/5 times, bring the 5 out front, subtract 1 from the original, secant tangent. And I'll pick this one up on the next recording.